This question is revised from a past paper, which is a typical example related to the grating. So here in the setup, you can see a person looking at the lamp and it placed the mark 1 meter from the grating. How do we know it is 1 meter? Because it's used a meter rule. So that another person use a pencil to indicate the position of the fringe that's observed by the student A, and it's found that at the position 0.37 meter, it can observe the first image. So in order to find the wavelength and related to the grating, we have to use d sine theta equal to n lambda. But how to find the theta? We have to use the tangent, because you can see the two rulers and the pencil form the triangle, so we can find the angle with the tangent. So actually, in grating, the d sine theta equal to n lambda usually work together with the tangent, so that we can solve all the problems actually. So we can find the lambda by using these two equations together. And then for part B, if the student keep moving the pencil along the meter rule, and now it's trying to locate the second order of the yellow light. So to predict the position, so once again, we have to use the d sine theta equal to n lambda to find the angle first. So after we get the theta 2, which is the angle from the center, once again, because we're looking at the position, that means we want to know the distance x, so we can use the tangent theta equals to y over d in order to find the position of it. And then state one advantage and disadvantage of observing the second order compared with the first order. This question is about if we use the second order to find the lambda, or we observe the first lambda to find the lambda. What is the advantage and disadvantage? Now, using the second order, we have a greater angle, so it is more accurate, because if we have some error there, because the angle is larger, so comparatively, the relative error will be smaller. But the second order is less bright compared with the first order fringe. So comparatively, it may be more difficult to be observed. So these are the advantage and disadvantage of measuring the item with the first order and second order of fringe. Then the next part is about the precautions. Now, every time in physics we're asking about precaution. Is this about safety? Most of the time, nearly all the time, it's not about safety. It's about the accuracy of the experiment. So the precaution is the lamp, to put it further away, because it can become a distant light source, so that the light ray approach to the observer will look parallel. It will be more parallel, because the light itself is not a parallel light source, but if we go further, then it will be like this. And for part D, if the filter is removed, now actually the lamp is not a yellow lamp, but just a common lamp, but using the yellow filter. So when a filter is removed, that's why it's actually a hint about the white light. So we draw the spectrum that we can observe. So in the middle is the white light, and because in the figure we not focus on the left hand side, so we just draw the right hand side is enough. So we have the second order spectrum, first order spectrum as shown. The violet is at the inner edge, and we should remember the third order is overlapped with the second order. So we have to draw a figure like this.